All right, now that we've been able to actually talk about how we do nuclear decay problems, what I want to do is actually do a few examples to get you started to help you with your homework for tonight. All right, so basically what we're going to be doing is we're going to be solving these for missing pieces of the equations. So for this, and in order to reference all the information that you're going to need, you definitely need to have your periodic table out. In addition, you need to have your notes for the different types of radioactive decay as well as the subatomic particles, because any of those can be some of these missing pieces. So let's take a look at number one. With number one, we have the single substance, uranium, on the reactant side of the arrow. Remember, our arrow is kind of like our dividing line. So if we look at the top numbers there for mass, we take 238, and that is going to equal, there at the dividing line, 4 plus something. And when we solve for that something would be then 234. This number then becomes the top number in what we were missing. Looking at the bottom then, I would have 92 equals 2 plus something, and that something would be 90, which comes over here and becomes that bottom number. Now if you look at the other parts of the equation, we also have a symbol involved there, so that's what I also need to include. I'm going to use this number here to help me find that symbol. That symbol, remember, is the same as the atomic number, so if I look on my periodic table for the atomic number of 90, I end up with the symbol of capital T, lowercase h. Now my equation is balanced and it is complete. Let's take a look at number 2. For number 2, for my top number, I would have 226 is equal to 222 plus something. And again, that something, 222 plus 4, gives me 226. On the bottom, I would have 88 is equal to 86 plus something. In this case, that would be 2. I would put the 2 on the bottom. Now I can look this up just like I did on the periodic table, and I would put in the symbol He, but I also have another option. If you look at your radioactive particles, okay, you have another one that has a mass of 4 and a charge of 2, and that is your alpha particle, just like this one up here. Either one is fine. One is not more correct than the other. You would not get any credit taken off for either one. Either answer would be acceptable. Okay, number 3. We have 231 is equal to 0 plus, well, obviously, 231 goes in there. Now the bottom you need to be a little careful. 90 equals a negative 1 plus something. That negative 1 would be the same as being 91 minus 1 gives me 90. So I need a 91 there. If I look that up, I am capital P, lowercase a on the periodic table. Number 4, on the top I have 40 is equal to 40 plus 0. So it's going to have a 0 on top. And then I have 19 is equal to 20 plus a blank, which would be negative 1. Now this one I definitely can't use my periodic table for because I don't have any element that has an atomic number of negative 1. But if I look at my subatomic particles and my radioactive particles, I can actually have two options. I have a beta particle, or, because those are the same thing, that is an electron. Okay, so let me move this really quickly so we can do the other ones on the paper. There we go. At least get to number 8. All right, so starting with number 5 here, we actually, instead of having one thing on one side and two things on the other, this time we have 2 and 2. And we solve it just the same way. If we look at the top, we would have 238 plus 4 is equal to 1 plus something. Well, this here, if I combine those, that is 242. So 242 is equal to 1 plus, so that number is going to be 241. On the bottom, I would have 92 plus 2 is equal to 0 plus, and in the blank goes 94. And looking up element 94, I would have plutonium. For number 6, on the top I have 14 equals 0 plus, obviously that is 14. And on the bottom I have 6 equals negative 1 plus a blank, which is 7. When I look up atomic number 7 on the periodic table, it is capital letter N, which is nitrogen. Number 7, I take 32, and that is equal to 0 plus, obviously, 32, which goes there. And then on the bottom, 17 equals 1 plus a blank, which is 16. Looking that up on the periodic table, that is S for sulfur. Now number 8, this number here, that 2, becomes a bit of a trick for us. It's called a coefficient. It would be the same as writing 2x, which means I have 2 of x. In other words, x plus x equals 2x. You're used to that from algebra. So what this is saying is I have 2 neutrons. And just like this coefficient multiplies x by 2, it multiplies our neutron information by 2. So I would actually multiply both the top and bottom number here by 2. So when I set this up on top, I would have 241 plus 4 is equal to 2 plus something. Now 241 plus 4 gives me 245, so this something, 243 plus 2 gives me 245. And then on the bottom I have 95 plus 2 is equal to, now 2 times 0 is still 0, plus, oops, not equals, something, and that something is 97. So when I look that up, it is capital B, lowercase k. All right, now for the last two. All right, taking a look for number 9, 226 is equal to 226 plus 0 plus something. Well, that obviously has to be a 0. So my top number here is a 0. On the bottom I have 88 equals 87 plus 1 plus something, which is also a 0. You have to look on your radioactive particles again, and this time it is the gamma ray. So our last one, 10 plus 4 equals 0 plus something, which is 14. And then on the bottom, 5 plus 2 equals 1 plus something, which is 6. And that is carbon. So now that you know how to do this practice, you have a homework worksheet that uses the exact same principles. You will again need your periodic table as well as your list of your different subatomic particles and radioactive particles in order to complete this.